Good morning and welcome to our digital discovery webinar this morning. My name is Matt Minner. I'm with Catalyst Connection, and today we're excited to have Eric Summit with GrayMatter Robotics. Good morning, Eric, and welcome.
Thanks, Matt. Welcome. Great to be here. Looking forward to explaining how AI and things are changing the manufacturing landscape across the U.S. and the world.
Well, excellent. Well, we're excited to hear about that. And just a couple minutes here, we will go over our Digital Bridge program, which is actually bringing this whole webinar series to us. And this is through funding through the Economic Development Agency. And this was a program that started in 2023, part of the Southwestern Pennsylvania New Economy Coalition. And our whole focus in our segment of the project is to support regional manufacturers with technology adoption and helping to build awareness and in the end get towards implementing technologies on the factory floor, but with awareness and of technologies like GrayMatter that we're going to hear from today. We're part of a whole organization. Catalyst is the lead, but we work with a number of organizations across the region, including the University of Pittsburgh, Carnegie Mellon Manufacturing Futures Institute, and the Digital Foundry at New Kensington, along with a number of other partners to bring lots of resources to the region and to our small manufacturers, which is a focus of our program. We have a wide range of resources from technical assistance, leveraging R&D facilities and demonstration facilities, and including access to capital. So in addition, through University of Pittsburgh, we have some great opportunities to engage with students, with graduate students doing technology-focused projects. And these do apply. Oops, all right, one a little too quick there. While there are focus today on robotics, our focus for the program is not so limited. It's across the spectrum of technologies. And we will have more sessions coming up, so stay tuned. But in the meantime, look at our Digital Discovery on Demand, which you will be able to see this webinar and all the others on demand. So with that, as we're going through the webinar here, I'll make Eric the presenter and he can start the show. But if you have any questions, please put them in the questions panel or just in the chat window. I'll be monitoring and we'll get started from there. So here, Eric, I just made you the presenter. So you should be able to start your presentation.
Okay, thank you, Matt. Hold on one second. All right, so GrayMatter Robotics was founded in 2020, and it was all about bringing artificial intelligence and robotics to the forefront of manufacturing and to help with one of the major problems that many companies around the world are facing, and that is a labor shortage. Most companies today have jobs that are dirty and dangerous and can't find enough workers to fulfill that need. So our two co-founders said, why don't we use technology to help solve the problem? Because the problem overall looks like it will get worse over time as the baby boomers continue to retire and we are not having enough people coming into the workforce to fulfill these jobs. So this here is just a look at one of our systems, and we'll get started here. So as I mentioned, what are we seeing? Here's an environment where it's dusty, dirty, and humans are doing the work. In this case, the labor shortage, I'm sure many of you are aware. There's news about it almost every day. There's also news about AI almost every day. And we're going to bridge those together as we move through things today. Here's a great example of a common workplace across America where it's very interesting to see how people sand. You can also notice that human sanding is not as consistent when you have constant force from a robot, and we'll walk through how all that happens. Plus, it's very challenging on your body to do all day, every day. What most people are familiar with with robotics and automation is car plants. There are hundreds, if not thousands, of robots in car plants, but they make the same thing and do the same thing every day. And they spend millions, if not billions, on fixturing to make sure things are exactly precise. And that's one of the issues that we think we've solved in the marketplace, is to not have to use great precision fixturing to be able to adopt automation. Here is a more common look at most manufacturing is a very different parts coming through, and to be able to automate and teach a robot to do all these different parts takes immense amount of programming, which is where the use of AI comes into place with GrayMatter Robotics. So our mission is to be able to give manufacturers around the globe rapidly deployable solutions with AI infused in them that allow them to basically have superhuman abilities and perform tasks autonomously with great speed and quality. And we'll walk through some customer situations where you'll see the actual ROI, how long it took, what happens with consumables because you're using automation. And there's some really great videos to show you different applications across the US. Most manufacturing in the US, about 95% of it is high mix, high variability, which doesn't lend itself very easily to automation. Many people are searching for solutions out there. 4 years ago, they didn't even exist where you could actually have a robot program itself. But today they do through GrayMatter Robotics, and there are other companies in other industries that do it for like welding and things like that. So what does GrayMatter Robotics really do? We take off-the-shelf hardware. So this is any robot from Fanuc, Yaskawa, any sensor for vision to allow the robot to see the part and scan it. And then essentially any tool. We can spray, we can trim, we can sand, we can polish. We combine that all with the GrayMatter Robotics artificial intelligence and the very simplicity of the GrayMatter Robotics user interface. It is literally set up to be run almost like a microwave, where you put your food in, you hit a couple of buttons and you walk away and you come back and you know what you're expecting. The cells are designed to do the exact same thing and require zero programming. And we'll walk through that further as we get deeper into the presentation. Here's a look of a subset of parts that on projects that we've worked on. Everything from the upper left is an outdoor light. The middle, I'm sure you all notice, is a bathtub. On the far right, those are hard tops for boats. Down left is acrylic sanding, customers that do aquariums and pools and hotels that are optically clear, take immense amount of sanding. Helmets, and I have to move my thing on the far right. And then lastly is guitars. So you can see a great subset of different substrates, items, manufacturing, all with high mix, high variability. And this is a quick video demonstration of essentially how easy it is. You saw the operator click 2 buttons. The robot starts moving across. It scans the part, and in a couple of seconds, you'll see what the artificial intelligence does. Right here, you will see in green, there is essentially a tool path. That is the robot programming itself after the vision system has identified the part in front of it. You also notice this, you only see about half the part because that's the limitation of the reach of the robot. It knows it can only go so far. If I took the video all the way through, they flip it around and it will sand the other half because it recognizes that it's different and didn't do it already. But you can see in this user interface on the right side, this is what a manufacturer worker would see. They would literally bring the part in. They would use 2 brakes or 4 brakes on the wheels in this case to keep the part locked from moving. and hit one button and walk away, and they would come back to a part that has been essentially 80 to 85% sanded. In this case, you will see there is green, no green in certain areas, and that's because the end effector just can't reach it. Here is a 2-robot system that is running on 2 RV caps autonomously. It's changing its own sandpaper as it's running the algorithm from the point cloud from the scan. This video is sped up to show you just how 2 systems would work together on 2 parts. So one works half of one part, the other on the other, and then they switch and do the corresponding part that they haven't done in section. This customer was doing it with humans and could do roughly 2 an hour, and now they are at roughly 7 or 8 an hour. Automation is the journey. This created subsequent bottlenecks in the paint operation because now they were being sanded so much faster and they hadn't experienced that before. So it's great to note that just because you've solved one area with automation, you may potentially create another one somewhere downstream or upstream. This is just to show you that regardless of geometry, this system does not run on a rail and actually uses a camera to take pictures of the helmets as they rotate. Creates a point cloud of the helmet. These are 2 different helmets you're seeing at the same time, and then it is off and running and has programmed itself. In this case, it's about 90% where they've been able to sand that helmet, but there are certain geometries that it just can't hit. So the rule of thumb is 80-20 for this type of automation. The robot can do 80%, roughly 2 to 4 times faster, and allows an operator to be able to place 2 new helmets in this case, or 2 new whatever, and finish up the parts as the next cycle is going. This is really a great visualization to see how different automation is from actual human sanding. The top photo, you can see lines that are happening across this. This can also happen if you don't have the right programming for a robot, but if done correctly, you can have it look nearly perfect. And so this is what happens with your quality. You get repeatability. You almost eliminate rework, which you'll see in a customer testimonial at the end. But it's truly amazing what robots can do, and it's so repeatable. This takes you back to design for the shop floor. These are 2 different parts from a semiconductor industry. You can see that even if it has raised profiles on it, the vision system picks that up and can absolutely figure out where it is and go right around it. So again, no human intervention, no knowledge of programming, and this part is often running in literally minutes. My background from 3M days, this was truly something we always looked for, to find something to automate sanding because it was always difficult. But now that it exists, it's truly amazing what's happening on shop floors around the country. This is a very new technology from us. Many of you might recognize this part. This is a bulkhead in an airplane. With simple tape detection, we can put an X and outline an area that we don't want the robot to go into, and it will recognize that in the scan and sand completely around the area. So this could happen in 2-tone paint. You want one area sanded for a different color. Or this example is sanding a Bondo on a bulkhead. They just want certain areas touched up so they can finish them. But this technology is really revolutionary. And you can see it's working the inside of that little box because there's no X. And this is a one of a kind. I have never seen this anywhere else. And to date, nobody that I've showed this to has also seen it anywhere else. It's truly amazing. So just to show you how easy it really is, this happened at the 3M Open. You may recognize these stars from the golf world. You can literally place this object anywhere, and even a small child at the age of 5 can program the system. This is pretty neat to watch, that it's truly this easy. That is the extent of how difficult it is to have one of our systems running. So one of the great things about how GrayMatter Robotics has gone to market is utilizing a model called RaaS, which is robot as a service. You're essentially hiring a digital worker. You remove all of the requirements for huge capex expenses up front. This allows you to do this without taking any risk. It can be deployed. One of our off-the-shelf solutions can be deployed as quickly as 90 days on your floor. Your ROI is almost instantaneous because you're not having a huge capital outlay. The other thing is we can train as many shop floor workers as you would like, but it takes roughly less than an hour to train someone to run the system unless they're a super user and going behind the actual user interface to change things. We're also keeping live monitoring of the system, both for output of the results and data for manufacturing, for management, engineers, also for our team, service team, to see exactly what's happening as things progress during a day. If it misses a piece of paper from the sandpaper changer, our team is being notified in real time that something's wrong. Many times we're contacting a customer first before they know that something is actually wrong. So it's 24/7 support. And what's really starting to take shape after the number of systems we've deployed is the amount of data we're seeing and what companies can learn about their own operation. Here's an example of a customer that had an application. This is for an engine on a propeller type plane. The objective is to not remove Bondo completely, and reaching the material is okay as long as it's not damaged. And considering all the above, we had to help actually teach some of their operators to give the right amount of Bondo on an application so we could identify and sand it precisely based on what they were looking for. On the left was how they were doing it. On the right is what we came up with. This is an example of their shop floor. On the left is how they were doing it. On the right is how it was automated and running with our AI technology. You can see how clean the cell is and how quickly it's being done just by a robot versus what's happening with humans with very different parts in a very different environment. This is all within the same facility. This is a dedication to what knowledge we have on staff, and the support that we bring forth. The staff has roughly 40 years of experience in abrasives, so that's really our core, especially now as we're expanding into grinding and other areas of expertise in that sector of abrasives. The other part is remote and on-site technical. Literally, if something goes wrong, we have somebody on site in 48 hours because we have a team across the country that can in the field. Also, then we have 95 to 97% uptime with our systems. Most 95% of issues are resolved just by having somebody remote in and look at things and diagnose them quickly and get you back to producing parts and making money and getting further return on investment with your system. Here's just a quick example of a worker texting our support team because they knew something happened. And it's really, truly amazing how this happens in live time and everybody sees it across the organization that's involved in the support team. So somebody's always monitoring it at some point. Here's a quick example of applications: sanding, grinding, spraying, blasting, polishing, buffing. Buffing is something truly amazing that was very, very difficult to start out with, but now is really come a long ways. And it's a very dirty job that most people don't want to do. So here's customer testimonial. Lawrence Brothers Incorporated. They are in the mountains of West Virginia. Started in 1974. They came to us because of major labor issues. They weren't able to find workers to be able to make these boxes. These boxes are for forklifts. They hold the batteries. There's tremendous demand for them, and they need to be ground on the edges and then sanded for prep for powder coat. Oops. So in this situation, we were able to allow them to take 5 workers and upskill them into other areas while the robot took over that labor. And we were able to exactly produce the number of units they needed per shift. And as long as it is fed, early on, they noticed that some of those things did happen and it was hard to feed the system. But they had an ROI within 2 weeks. Consumables were reduced by $2,000 a week and almost covered the cost of the system for 1 year. So this was truly an interesting grinding. So we grind all 4 edges of the box and then sand it in another cell. So they have almost fully automated this process. They have some automation in welding, but it takes them roughly 5 to 6 hours for them to program some of these boxes. Ours takes less than a minute as it scans these boxes. It does 4 at a time, and it's off and running on its own. McLaren Composites is another one where they had a same situation of finding operators that would do this job and keep them in the same job. So I'll take you through complex high part mix. They do parts for companies like PACCAR, Freightliner, large composites. It's a pretty dirty environment. As you can tell, everybody's wearing a dust mask. It's very hard to automate these complex geometries. It would take an immense amount of programming and fixturing, and the workers just weren't motivated to do this. Here is a look of the solution. You have one rail running about 8 meters. You see the safety guarding that is required for sanding. And then there are 2 light curtains that if somebody walked in, it would immediately stop the system. Here's a great look at how easy fixturing can be done. This is literally 2x4s put together that they put the part on just so it won't move within our tolerances to keep the system running. This can then be scanned and sanded in much less time. I'll show you here moving forward. Here's a great picture that reiterates on a customer's shop floor. The user interface literally has to hit one button. And here is the outcome. So 67% less time required to prep the part with a robot compared to humans. They saw a tangible ROI in 90 days after deployment, 30% increase in efficiency of multiple product lines, and then half of the shop floor operators immediately upskilled to higher demand positions. So this goes back to everything that I mentioned in the beginning of this presentation about how automation and AI can really change a shop floor. Here's a great quote from one of the leads on the floor. They were very doubtful the quality of what a robot could actually do because it's a robot, not a human. But after running the cell, they know they can get it done, and they don't worry about hitting deadlines anymore because it can be done much faster, and it makes life much easier, and the environment is much better as well. The slide deck just messed up. This goes back to the Lawrence brothers. They're in a remote area, can't find workers, high turnover. Here's the cell with the boxes in it. Here's a great image. They have the boxes come in on little, they're like rails, and then they can rotate them. They can bring them in and out because they need to, when they turn them, they can only run 4, so they have to bring some out. And here's the formal outcomes from there. They had a 38% boost in production rates through the cell. They saw an ROI in a week. I mentioned the reduction in consumables of $2,000. And now with 2 cells, 10 to 12 employees have been upskilled to more higher demand positions. And that really sums up what AI and robotics is doing for manufacturing, which is the backbone of America. And we hope that continues, and we can continue to help manufacturers across the world. Matt, that takes it back to you.
Well, fantastic. That was a great presentation. Thanks so much for taking the time with us, Eric. We have a few questions that we've got here. So you mentioned a 90-day deployment. Is that common, or what's the typical, or what's kind of some of those more challenging projects? What's kind of the range that you would think with these types of projects? What have you seen from when the first time you talk to a manufacturer and they're interested to get it going?
So 90 days is from a signed agreement to deployed on the floor. But you can have anywhere from 30 days to a year in that initial process, because automation is a disruption, right? So people have to plan accordingly. There's a lot of stakeholders in many organizations that need to be involved, from facilities to safety to management. So there's a lot of things that need to be aligned. So it really runs the gamut of the time frame. But if it was signed today, for example, it would be running on somebody's floor, if it's an off-the-shelf system from us and not a new application, in 90 days, if they want it. But you know, they have to run power. There are things that need to be done for the system to be activated. If it wanted to move fast, it can move very, very quickly. A traditional systems integrator, from a signed contract to deployed, is usually between 6 to 9 months.
Okay, and you showed a lot of different applications that you have. How many systems did you currently have running?
We currently have, I think as of today, is 50, but that changes every week.
Yeah, that's very, very exciting. Excuse me. And a lot of manufacturers, they may have, like you showed, the metal fabrication. You know, maybe they've got a significant need on the grinding or sanding side, but maybe they don't have, say, multiple people that are dedicated to doing that all day long, but they've got maybe someone who spends half the time, or they're bouncing, they maybe spend some time welding, spend some time grinding. With all these projects that you've looked at, the ones that have gone, the ones that haven't, is there a common denominator around how focused they need to be, how much time that has to be into these different applications to make it worthwhile?
Typically, somebody would need 3 or 4 people in that operation to justify the ROI of a system. For it to be an ROI, like you saw from one of these customers, either 90 days or 2 weeks after deployment, which is an incredible ROI for an automation system, where it's typically years you're measuring ROI, not weeks or days. But 3 to 4 operators is roughly what can be replaced from a labor standpoint with one system. And then we've never seen anybody lose a job from automation, it's always been upskilled to other areas of the plant because it's essential that something else is going to be a bottleneck with automation.
Right, right. And then I'm interested too. There's the quotes around some of those more rather surprising ROI time, or time to where they're seeing ROI. But how do you evaluate that when? Because you said it's all on a robot as a service model, so it's like a monthly fee. So is it based on their monthly fee that ROI is based? Okay, so you're not looking at
based on a monthly fee. Their ROI is, so Lawrence Brothers, for example, was 2 weeks because they were able to move 6 people to another area, mainly to welding, to feed the cell. That's why their ROI was much quicker than McLaren's, for example, which took 90 days. But it's because of the model, not because of a capex situation. That would have taken years.
Right. Okay. Yeah. No, that model certainly makes it a different calculus. So that makes a lot of sense. Well, I think that wraps up the questions we had. So I really appreciate you taking the time today, Eric. And again, just for everyone on the line, we will be sharing this webinar recording out. So you'll be able to review or share with other colleagues who may be interested. So I just want to thank you again for taking the time, Eric.
Thanks, Matt, and appreciate the opportunity to present on your platform, and I look forward to any further feedback.
Yes, absolutely. We'll certainly be in touch. So yeah, and to Eric's point, if anyone has any follow-up questions, certainly reach out to me. Or we can get everyone in touch and make the right connections there. So thank you very much, Eric, and everyone have a great day. Take care.